Welcome to Investigation 3.1. This is rectangles with fixed area. So our focus question for this particular investigation problem is this. When the product of two variables is the same, that should say same, is the same fixed number, what is the pattern of change and how is that pattern of change reflected in tables and graphs of that relationship? So essentially we are going to be looking at if we have a rectangle that is, say, 36 square inches, so let's actually make this rectangle. We'll say this has an area of 36 inches squared. How do the length and the width of that rectangle change in accordance with that fixed area? So what we're going to be doing is we're going to be making a table, and then we're also going to look at the graph of that table. So let's create a table. We'll have length and width, and we are going to try out multiple different lengths for this particular rectangle. So what if the length was 1 versus 2, 3, 4, 5, and 6. So we'll try all of those different scenarios. Then our job after that is to actually create an equation for it. And so we're going to try to relate the length and the width in accordance with an equation of some kind. So if we think about it, the area of a rectangle, if we were to look at the formula for it, we usually say that it's this side times this side. If we multiply those two sides together, we are essentially looking at everything inside that particular rectangle as the area. So we can say its length times the width is equal to the area. So if that is the case, if we know our area is 36 and we have a length, in this case of 1, what number times 1 gets us 36? Well, the number 36 does. Let's try another one. If we have instead of the length of 1, let's try maybe a length of 2. 36 times, or 2 times what gets us 36? Well, hopefully you guys are screaming out 18. Yay, fabulous. We can do the same thing for 3, 4, 5, and 6. So hold on a second and I'll magically appear. So magic, we have the rest of our table filled in. We have essentially 12 times 3 will get us 36. 9 times 4 will get us 36. And I'm going to jump over to 6 times 6 gets us 36. Now we also have this funky one of 36 divided by 5. How did I get that? Well, let me think about it. If I had 5 for my length and I'm multiplying that times a width I don't know, and I need to get 36 out of it, I know that 5 times a number is not going to be really simple. It's not going to be easy. So one thing that I could do is I could divide this left-hand side by 5, and I could divide the right-hand side by 5, and I get the width is equal to 36 divided by 5, which is kind of cool. Essentially, what I'm noticing with an equation is essentially I'm taking the area and I'm dividing the length from it, and I'm getting my width. So let's plot some of this information into a graph. I'm going to erase this really quick so it's not in our way. Let's plot some of this information. We have some graph paper over here. I'm just going to move this over a little bit so we can see it. Let's make every 2 of these babies be 1 unit. So we have 1, 2, 3, 4, 5, 6. And we need to do the same thing up here. 1, 2, 3, 4, 5. Oops, actually, I'm going to need to change that scale on that side. So let's talk about that really quick. Essentially what we are seeing right here in the length aspect of things, we have 1 through 6. So that's easily doable on this graph. On this other side, though, for the width, we go from 36 all the way down to 6. So technically we need to think about a scale that's going to work well for this particular graph. When I look at this graph, actually, it is 20 units wide by 20 units long. So let's actually use that to our advantage. For every one of these little tick marks, we'll say that's equal to 2. So I'm going to mark off every 5, which will be 10. 1, 2, 3, 4, 5. That's 10. 1, 2, 3, 4, 5. That's 20. We're going to do the same thing. 1, 2, 3, 4, 5. That's 30. And then our last one is 40. And we're going to do the same thing vertically. Hold on and it'll magically appear. So magically we have our length and our width, and as we know, we need to pay attention to dependent versus independent variable. In this case, we were saying the length is determining the width, so our length is going to be on the x-axis and our width will be the result of that, so it will be on our y-axis. It's our dependent variable. So now let's do a little bit of graphing. When the length is 1, the width is 36. So we need to go from 1 up to 36. And we are going to make a little dot somewhere on that line. For 2, we have the length of 18, or the width of 18. When we have a width or a length of 3, we have a length of, or when we have a length of 3, we have a width of 12. When we have 4, we're at 9. When we have 5, we're at 36 divided by 5. 36 divided by 5. Let's do that math. So if we think about it, 5 goes into 36 7 times, and we have 1 left over, and 1/5 is 0.2. So we have 5 and 7.2, so somewhere in there, and 6, 6. So as we can see, this line that we're creating is not actually linear, perhaps. If we were actually going to extend this table, we could try 7, 8, and 9, and if we were to do that, we would find eventually, if we had a length of 9, we'd have a width of 4. I chose that one because we're starting to see a mirroring of these various numbers. Essentially, the length and the width switch places. So if we were to mirror all of this, we could also get the rest of this down. So I'm going to go to 3, or I'm going to go to 12 on our x-axis, and then we go up to 3 on our y. If we did 18, we're up to 2 on our y-axis, and then 1 would be 36. So there is our graph of this scenario, of this area or rectangle scenario. So looking at this, we could actually create a line in here, and our line would be nice and curvy, and it would be kind of fun. And essentially what this is called is an inverse variation. So what we're noticing is if we have a fixed area, if we have an area that does not change, it's always going to be 36, we will essentially create multiple different rectangles that have different lengths and widths that will always multiply to be that 36. But essentially, if the length increases, the width decreases, and we can also say the same for if the length decreases, the width will increase. So that's the concept of an inverse variation. I'd like you to try your hand at the homework and see how you do on it. Be sure to come to class and ask questions. Ciao.